the impact of the most prominent and intuitive features, I'll now begin by walking you through how tasks were traditionally performed. Then, in the second round, I'll demonstrate the same tasks and how they're accomplished using the automated features. The subject matter expert traverses a few frames to understand the sequence. They redirect to the first frame and identify a cluster of points as an object on the scene. They move through the sequence again and identify the frame that captures this object with the most LiDAR returns. A cuboid is created. The subject matter expert moves to the focus mode, reduces the brightness of the points outside the cuboid, and views the annotation from the front, side, and top, and adjusts as needed. Simultaneously, they adjust roll, pitch, and yaw. The subject matter expert looks at the annotation from the bottom to make sure that ground points are not part of the annotation accidentally. Once the desired accuracy is attained, the expert proceeds to assign the attributes associated with the class on each frame, ensuring the annotation is comprehensive. These attributes may change throughout the sequence for the selected object or may not. For instance, capturing is in construction zone will need to be updated when the vehicle moves into and out of the construction zone, requiring the expert to update the value frame by frame. In addition to updating the property values for dynamic objects, the annotator tracks the object's movement by repositioning it on intervals across the sequence to maintain accuracy. If this were a stationary object, the expert would move on to the next object without repositioning the annotation. There are two types of objects that appear stationary in a scene: ones that never move, like trees, traffic lights, buildings; ones that can move, like parked cars or pedestrians, but remain still during the sequence. Once the user has completed their work on the point clouds, they proceed to the 2D images to identify and annotate objects. This process closely mirrors the steps I just covered for cuboids. At the end of all the identifying and annotating, the expert marks their task complete. This was how the expert would use the tool to annotate. This time, let me demonstrate the same use case with the smart automation. The subject matter expert, rather than navigating through the sequence, activates the merge point cloud feature to gain an overview of the sequence. As opposed to last time, the next step is to identify all objects that are stationary in the sequence. A cuboid is created without the need to traverse the sequence multiple times. The focus mode has transitioned from relying on multiple clicks and hotkeys to providing a seamless, unified view of all three sides: front, back, and side simultaneously. Leveraging ML, the point cloud is segmented into two distinct regions: ground points and non-ground points. This ensures that the expert no longer needs to worry about accidentally including irrelevant points in their annotations. By simply hiding the noise, they can focus on creating precise and clean annotations effortlessly. The annotator will use the autofit feature to ensure there is zero space between the edges and the LiDAR returns. For the dynamic object, the user need not traverse all frames to reposition and can now skip an interval and reposition. The tool automatically places the cuboids in the intermittent frames as accurately as possible. The attributes are provided like before, but this time attribute values propagate forward automatically, significantly reducing manual effort. For instance, with the attribute is in construction zone, the expert identifies the first frame where the object enters the construction zone and updates the attribute value. This update is then propagated forward across subsequent frames. The expert only needs to identify the next frame where is in construction zone changes and update the attribute value there. Once updated, this value is again propagated forward, streamlining the annotation process. With the help of the visual timeline representation, this feature minimizes manual errors and aids in a thorough review. Once the user has completed their work on the point clouds, they will proceed to the 2D images to identify and annotate objects. However, the tool leverages the effort invested in creating cuboids to assist in identifying, locating, and annotating objects using rectangles. The generating rectangles from cuboids feature utilizes the 3D annotations to automatically project bounding boxes onto the 2D image. This feature reduces manual effort and aids in identifying objects through projections that might otherwise be overlooked in a purely manual process. At the conclusion of the identification and annotation process, the expert can utilize validation to re-verify their work by checking for logical errors. This validation script serves two primary purposes: enhancing the overall task accuracy and providing an opportunity for expert retraining.